do a problem which was asked to me during my Amazon interview, this back in college. And so we were applying for Amazon internship, and this is one of the questions they asked, when we were part of the interview. I guess this was before we actually go to the on-site, but it so the Amazon came to our university to conduct this. So we are given a question where you're given a coins and a total amount that we want to reach, and we want to ensure that we get the minimum number of coins. So here's an example where if you have 11, the minimum number of coins is 3 because 5 plus 5 plus 1. Same thing if you have you know 3 and you have just 2 2 rupees basically, you can never reach it because max you can do a min of 2 or max of 4, so it's return -1. So initially when I was given the problem, the way I tried to solve it was brute force. I tried sorting the array, starting from the largest number and keep moving down to see if we are able to reach the correct change. But that wasn't the correct solution, and yeah, the correct way to solve it was using dynamic programming. So I won't give a big overview of dynamic programming, but essentially the concept is you divide the problem into smaller sub-problems and you store the solution of each sub-problem. So later when you're trying to get the solution of, you don't have to recompute everything. So you have the solution of smaller sub-problems available to you, and we use that as a basis to get the final result. So for example, here I've given a case where we have 3 coins, 1 rupee, 2 rupee, and 3 rupees, and the amount is from 0 to 5. So what's the minimum number of coins we need to reach 0? So basically we don't need any coins at all, so we can just strike it out saying that, hey, we don't really need this. So here the minimum amount is just 0. So this is what the first thing we need to do. Then what's the minimum number of coins to reach 1 rupee? So we just have 1 rupee coin, so we get 1. So here it's impossible since 2 and 3 are greater than 1. So what's the minimum is 1. Same thing, for reaching 2 rupees, what's the minimum number of coins we need? So if we add 1 rupee coin, we can add 1 plus what's the minimum to reach 1 rupee? So it does 1. So 1 plus 1, 2. So here if we have 2 rupee coin, what's the minimum number to reach 0? Here the answer is 0, so it's just like 1. Here we can't even consider. So to reach 2, the minimum number of value we need is just 1. Same thing for reaching 3. So if we add 1, if we add 1 rupee, what's the minimum number to reach 2? Since the answer is 1, it's 2. Same thing, if we have a 2 rupee coin, what's the minimum number to reach 1? Is 1, so we say 2. And if you have 3 rupees, what's the minimum number to reach 0, so it's just 1. Similarly, 4 rupees, we can say what's the minimum number to reach, sorry, let me just fill this up. So minimum is 1. For 4, what's the minimum number to reach this? So 1 plus 1, 2. Same thing, 2, 2. Now 5, so here the minimum is 2. We need 2 coins to reach 4 rupees at least. So same thing for 5. So if we have 1, what's the minimum number to reach 4? So it's 2, we say 3. Oh, sorry. And if it's we have a 2 rupee coin, what's the minimum number to reach 3 rupees? So since the answer is 1, 1 plus 1, 2. Same thing, if we have a 3 rupee coin, what's the minimum number to reach 2 rupees? 1, so we say 2. So minimum number is 2. So that's the answer. So in order to reach value of 5, we need a minimum of 2 coins. So that's what essentially we're going to code now. So let me first create a result, and let me actually first sort the coins. So this makes the solution a little bit faster. And then let me create a result array. So this result array will be the one which will do the computation which I just showed you. And we need to fill it up with some values. So arrays.fill, and we take the result, and I'll set it to integer to max value. And let's say file. And I think just like how you saw, we have just filled the first one to set it to 0. So here we know result 0. So because to reach amount of 0, we don't need any of the coins. So now we are going to traverse over the amount. So there's and then we have to go traverse over the coins. first thing we need to make sure is that if the coins this amount that we are trying to reach, then we compute. Else, there's no point processing the remaining coins. So that's the reason I sorted the coins in the beginning. So here we need to first calculate whether a solution even exists. So if so the reason I'm adding this condition is that here imagine there was no solution if like the coin 1 doesn't exist, for example. So if we don't want it to be like misguide the user. We want to store some kind of max value to indicate that this is actually impossible, this combination. So that's why essentially what I'm trying to do. I filled it with a max value indicating that no, the solution is not possible under some scenarios. So for example, here they're given it's 2 and the amount we're trying to reach is 3. So if that was the case, even though, uh, so imagine we are trying to do a dynamic programming, there's no way to get one coin, 1 rupee amount, so because of that, solution doesn't exist. So that's what I'm checking, whether solution exists or not. And if it doesn't exist, we don't even proceed with it. If it exists, then we just say so we make sure that no mean the existing solution is the minimum one, or we add the current coin. I said that's weird. Sorry, it's pretty late at night here for me, so I'm making a lot of mistakes. So yeah, essentially I'm doing the same thing I just demonstrated here. So let's first confirm a solution exists. If actually you don't need a if, return so if it is the integer max value, so no solution exists, return -1, else return result amount. So yeah, essentially this is I'm trying to show what happens if no result is possible. We just return -1. So let's try the solution. Okay, so all 3 cases passed. Submit. All right. So yeah, thank you everyone for joining, and hopefully the explanation was clear. If not, just leave comments, and yeah, I'll try to reply to them.